Hello everyone, I am Savitri Nagra, lecturer in Electrical and Electronics Department, Jain Polytechnic, Belagavi. I am handling the subject Fundamentals of Electrical and Electronics Engineering. In that, Unit 1, Direct Current, Electricity and Magnetism contains self-induced EMF, mutual induced EMF, self-inductance, mutual inductance. First we will know what is meant by self-induced EMF. The EMF induced in the first coil where the flux is produced. It is also defined as the EMF induced in a coil due to the change of its own magnetic flux linked with it is called self-induced EMF. This is the diagram of self-induced EMF, which consists of solenoid is nothing but a coil and magnetic field lines. When a coil carrying the current, a magnetic field is produced through the coil. If the current flowing through the coil changes, then the magnetic flux linking the coil also changes. According to Faraday's law, an EMF will be induced in the coil. This is known as self-induced EMF. Mutual induced EMF. The EMF induced in the second coil, which links a part of the flux produced in the first coil. This is a diagram of mutual induced EMF. The EMF induced in the coil due to changing current in the neighboring coil is called mutual induced EMF. Consider two coils, coil 1 and coil 2. The magnetic flux produced in the first coil passes through or links with the second coil. This magnetic flux, which is common to both the coils 1 and 2, is called mutual flux. When the current in the first coil varied, the mutual flux also varies, and hence the EMF induced in both the coils. The EMF induced in first coil is called self-induced EMF, and the EMF induced in the second coil is called mutual induced EMF. Self-inductance. The property of a coil that offers any change in the amount of current flowing through it is called self-induced EMF. The inductance of the coil is due to the self-induced EMF in a coil by changing the current flowing through it. When the current in the coil is increasing in one direction, the self-induced EMF is set up in the opposite direction to oppose the rise of the current. This is the diagram of self-induced EMF, which consists of flux line, flowing of current, battery, and EMF induced. Mutual inductance. The two coils arranged in such a way that the change of current in one coil causes an EMF to be induced in the other coil is called mutual inductance. Here consider two coils, coil A and coil B, placed side by side. If the current I1 flows in the coil A, a magnetic flux produced is called mutual flux, and the part of this flux links with the coil B. If the current in the coil A changes, the mutual flux also changes, and hence EMF is induced in the coil B. This induced EMF in a coil A is known as mutual induced EMF, which is responsible for mutual induction. This is the diagram of mutual inductance. Overall, in this lecture, we have studied self-induced EMF, mutual induced EMF, self-inductance, and mutual inductance.